This is the topic where we will study the partition function relation with the entropy. The first equation here that is mentioned shows that according to the Boltzmann equation, where it is said that small ni means selected particles divided by the total number of particles with their statistical value. Here you know that this small or selected ni is equal to this factor value, and this n, that is capital N, it is equal to the sigma small ni, and it is getting equal to q. You know where the ni value is equal to statistical weight factor e raised to power minus ei divided by kt. At the same time, when we take the sigma or the summation of the ni, it becomes the sigma ni, and when the sigma of this side is taken, it becomes sigma gi e minus ei divided by kt. That is the statistical weight factor exponential power divided to its component, so it becomes equal to q. So in that position we are putting the q. So when we apply the natural log on the left and right side, the equation appear in this way. There it is shown that the natural log ni is equal to the, this is the natural log, and why it is here, it is on the left side in the form of division, and when you will apply the natural log, it will become natural log small ni minus natural log n. So when you take that minus natural log n to the right side, it become positive, so here it is in the form of positive. All other fragments will be written in the same way by application of the natural log. As this q is in the denominator, so it is showing the negative natural log q, and this is the power, so no natural log is applicable over here, it is just coming in the same way. So when you multiply both sides by the selected number of particles, that is ni, so all the components of the equations are going to have the ni along with it. So when we are going to arrange the equation will be arranged in this way. This part of the equation will get nearby to this, or this factor is going to be nearby to this factor. So by combining these two factors, we will write it according to the natural log or the log rule, where it is said that the minus is equal to denominator. So it means that this minus factor will become the denominator, and the natural log and ni are taken as the common. The remaining equation is as it is. When we apply the summation on the right and the left side, the summation is being applied to all the factors of the fragments of the equation. So the equation appear in this way, and when you are going to change the positions of this n over q, means the total particle divided by the partition function, you will take this q upside and n upside down. So it means that when we are changing it by ourselves, it means that we will add the minus here. All other equation is the same. Here is the next page to be determined. On the next page, it is told that according to the modified probability factor, where this probability equation is showing here, that is the formula given, W is equal to G naught, N naught divided by N naught factorial, and then same goes for the number 1 molecule, number 2, number 3, and up to the infinite number of molecules. So it is the formula for the definition, or it is the modified definition of the probability factor. When we will take in consideration this equation, we will take the natural log. After taking the natural log, you know that all the denominator will become in the form of negative, and all other denominators will come simply in the form of positive, like n naught. This power will become the first part of the equation, n naught natural log g naught, and this factor is coming into the form of the in the negative way. Same goes with the next part, that is equal to, here is the dot that is representing to the multiply sign, so that is turning into the positive for the for taking the natural log. So in the next fragment of the equation, the same rule is going to apply in the next and next as it is. So the natural log w, where here the w means the number of ways in which the particle or the molecules can be arranged. So you can say that this w is equal to the microscopic states. When we are going to arrange the positive figures or positive part of the equation together, the negative part will get separated. When you take the negative as a common outside the whole equation, so the all other the components will become positive inside the bracket. So the overall bracket become in this way when you are going to apply the sigma, that is showing the summation of this whole part of the equation, and the summation this whole part of the equation, that is the denominator part of the equation, and that is the numerator part of the equation. So overall equation appear in this way. After that, according to Stirling's formulation law, you have studied this, where we say that n factorial is equal to n natural log n minus n. In the same way, we will talk about the selected number of particles, that is ni. By applying the same Stirling's equation, the formula appear in this way. So here we will apply the summation on the both sides, and the summation is equal to this. So when you apply this summation value, summation natural log selected part of the components or the particles in this equation, this value is replaced by this value, because it is this is equal to this. So when you are replacing this value here, the equation will become in this way, and here this equation has become. What we are going to do here, we are going to take the this one sigma ni natural log ni is equal to this, it will go to the left side, and all other factors are coming to the right side, or the right side factors are remaining at the right side. Only this one factor is coming to the left side, and only this one factor is coming to the right side. So by keep on moving, where what will happen, we are going to compare this finalized equation with the previous page equation. It is that one, the last one equation that we are going to compare with. This is the equation that we are going to compare with that finalized equation, that last one. So when we compare these two forms of the equations, the equal size of the equations are cancelled out, and the remaining are becoming equal to each other. So we can see that on the right and left side, these factors are cutting out or cancelling out the remaining factors. The remaining factors of the equation are in this way. And when we arrange the equation become in this way. You can see that in the whole equation, every component of the equation is having the negative value. So we can remove the negative value by changing the position of every equation, or by taking the another way is that we can take the negative as common from the right side. All other factor inside the bracket will become positive, and the negative will cancel out each other, and the overall equation become positive. Another way is that you can change or replace the value from the left to right. All the right factors will go to the left side, it will become positive, and when all the factors from the left side will be go to the right side, it will become positive again. So the equation overall become positive from both of the sides. We are going to study these components in detail when we take this part into the consideration. We know that sigma ni natural log q over n is equal to, where sigma ni is equal to capital N. So we can replace this small ni sigma small ni means selected particles. Overall sum of the selected particles will become equal to the total number of particles. So we can replace this sigma ni with the capital N, so that this part of the equation can be replaced with this part, and this part of the equation can be replaced with another factor, where we are saying that sigma, this factor is equal to 1 over kt is taken outside, and the summation of only number of particles at the infinity level with their energy is taken, means that the sigma of the total energy, because the total energy is equal to ni sigma ni and ei. So here we can say that we are taking the summation of only numerator part, and 1 over kt as a constant or remaining the same are taken out. Next, what we are going to do, we are going to put this form, this part of the equation, this we are going to put this equation part and this equation part in this in the part of these fragments of the overall or finalized equation. When you put the values here, the equation become in this way. What you have done in the previous equation that we got after the comparison and after the cutting out or cancelling out the equation, these fragments is replaced by the new one, and this fragment is also replaced. So the overall equation is in this way. You know that the E is equal to this. We have derived it in the previous equation. Then this one small ei, that is equal to the, that is the internal energy that will be replaced with this factor. The equation become in this way here. you know that here 1 over kt is taken already outside, so it means that here the sigma niei that is equal to the total internal energy, and this total internal energy is equal to this formula. So this part of the equation is going to replaced by this component. So we will put this value here, n plus n here, natural log w that is equal to, w is the number of ways in which the microscopic particles can be arranged. So overall equation, when we are going to cancel out this constant from the numerator and denominator, and this t square is also cancelled out by 1t, and the only one sign of the temperature is remaining here. The overall equation is can be solved by taking the n as a common, because n is a part of all the fragments of the equation. And here you know that Boltzmann-Planck's equation is equal to S is equal to K natural log W, where S is standing for the entropy, and W is the number of the ways in which the particles can be arranged. So the remaining, the natural log W value can be taken out. This W value, natural log W, will be replaced by S over K, and by putting the S over K in the equation, this S in this K in the denominator will become the numerator on the right side, and this na is going to be replaced with the Avogadro's number. So that is there is equal to na, this k na is equal to r factor, and here the equation overall become this way, and this r is going to be multiplied with all the components of the equation, because it is outside the bracket and showing that it is a part of all the components of the equation. The overall, the finalized and the equation for the relation of the entropy with the partition function, it is this is the most important long question, has repeated many times in the past paper, so prepare it well.